In the last lecture, in the last lab, we have discussed bubble shot. So did everyone complete with the implementation of bubble shot and insertion shot? Sorry, bubble shot and selection shot. Everyone? Do I need to show you the implementation again? Wake up, students. Students, do I need to show you the implementation again for bubble shot and selection shot? Or shall I move towards the insertion shot? Please reply. Okay. Before moving on, as far as your submissions are concerned about the practicals, you need to make a Word file of each and every practical. I'll be sharing the format in the e-content. Download that format, and in that format you need to uh, create a Word file for each and every practical. And I will be making the Google Classroom, and you will be submitting your assignments. There will be two assignments for the as far as your internal evaluation has been concerned. So there will be two assignments for the internal evaluation, and third is submitting your practical lab file. So there are three submissions you will be doing in the Google Classroom. I will be making the Google Classroom as soon as possible. I hope the submissions portions are clear to you all. Nextly, let us move towards the insertion shot. Is my screen visible to all? Okay. So I'll be directly going towards the tracing in how the tracing is done in insertion shot. Then we'll go to the theoretical portions. First of all, we'll learn that how tracing is done in the insertion shot so that it would be more clear to you with an example. So over here I have taken the array of 8 elements. What is What are we doing in the insertion sort? Insertion sort divides your array into two parts. The first is shorted one and the other is unshorted. So the first element of an array is selected as a part of a sorted array, and the other rest of the elements are as a part of an unsorted array. Next step, it compares the element of a sorted array with the unsorted array. If the element is less than the compared element in the sorted array, it will shift the element of the sorted array towards the right side and place and then check the other elements if they are there in the sorted array, and compares the element with each and every element of an sorted array. If the element is greater than the compared element, then element is shifted towards the right. At the end, at the end of an insertion sort and at the end of iterations, we'll be getting the whole array as the sorted array. Let us see. So 2 is compared with 9. 9 is it is the only element in the sorted array. So of course the only element in the sorted array will always be sorted. So 9 is compared with 2, and 2 is stored somewhere in the temp variable when you are comparing it. So now 2 is compared with 9. So 9 is greater than 2. Therefore 9 will be shifting towards the right side. Then again 2 will be compared to other element if there is any element in the array. Right now there is no element in the array before the 9. So 9 will be shifted towards the right and 2 will be placed in the place of 9. And the rest elements are as it is. So 9 and 2 are compared. Then 9 is shifted towards the right and 2 is in place of 9. So now after first iteration, 2 and 9 are the sorted element in the sorted array, and rest are the unsorted elements. Now the next element is 7. 7 will be placed 7 will be stored in the temporary variable. Then 7 is compared with 9. So 7 compared to 9, 7 is greater than 9, sorry, 7 is less than 9, so 9 will be shifted towards the right. Then again 7 will be compared to 2, but 2 is less than 7, so there will be no change. So 7 will be placed in the place of 9 and 9 in the place of 7. So after the second iteration, we are getting the elements in the sorted array are 2, 7 and 9. Anybody is having any doubts till this two iterations? Again, for the next iteration, we are having 5. So 5 5 will be stored in some temporary variable, so that position will be now empty. So 5 will be compared to 9. So 9 will shift right. One position right. Then again 5 will be compared to 7. So what will happen? 7 is greater than 5. Therefore again 7 will be shifted one position right. Now 5 will be compared to 2. No change, as 2 is already less than 5. So 5 will be placed in place of 7, and 9 and 7 will be shifted one position right. Then for the next iteration, Then for the next iteration, 1 will be compared with, first of all, 9. 1 will be stored in a temporary variable. Then 1 will be compared with 9. So 9 will be shifted one position right. Then it will be compared with 7. Again it will be shifted towards the right. Then 1 will be compared with 5. 1 will be shifted 5 will be shifted towards the right. Then 1 will be compared with 2. So again 2 will be shifted one position right. So 1 will be placed at the first position, that is A of 0th position. So at the end we'll be getting the sorted array in this form. Is it clear to all? Anyone is having any doubt? So how the insertion sort work is, it selects element, compares element. If the element is less than the compared element, then the compared element will be shifted one position right side, and then it will insert the element at its correct position. So at the end of all the iteration, we'll be getting the sorted array. There will be no unsorted element. Now moving on to the algorithm. The first for loop, that is for the pass. The second for loop is for iterations. We'll be initializing j with I, then I greater than 0, and a of j is less than a of j minus 1. Then we'll be storing array of j into temp, means the element at the jth position into temp, and array of j is equals to array of j minus 1, and then j minus 1 is equals to temp, and we'll be doing j minus minus. Any doubts? I'm keeping this pseudo code of an insertion sort as it is. that will be helping you in the implementation portion. So start implementing it, and if you get any doubts, just let me know in the chat box. Can anyone say why over here it is j minus 1? Array of j is the element from an unsorted array. Means the unsorted list. The unsorted list is this blue one. So this is array of j. So it will be compared to the array of j minus 1. Therefore, we are doing over here j minus minus, j minus minus will be going till the zeroth element, means the unsorted element, that is the 5 over here. We will be doing j minus minus until 2. So comparison will go until 2. Therefore, we are using j minus minus, not j plus plus, as we are not comparing it with the values over the right side of it. We are comparing it with the values left side of 5, and that is said to be the sorted array. So start implementing it. If there is any error, just let me know. Or else if you are done with the once you are done with the implementation, just let me know in the chat box. If you need the reference, just take a snapshot of a pseudocode just for a while. I'm uh, I'm stop I'm stopping my screen share. So just for a while, if you want a reference, then take a snapshot of a pseudocode. Students, once you are done with the implementation, just let me know. Hey, registration. Other than Deep, who has completed implementation or still doing? Can anyone share their screen and show the implementation code and explain what you have done? Anyone from you? Okay, I will be sharing my screen and showing the implementation code. Is the code visible?
Yes, ma'am.
Okay. So the same logic as explained you in the PPT, the pseudocode, the same I have implemented over here. For the number of elements in the array, I have taken the variable count, and the array taken as number of I. Each and every time I have stored the number of I in the temp, then j is equals to I minus 1, then while temp less than number of j and j is greater than or equal to 0, and then number of j is j plus 1 is equals to number of j. This logic is for comparing each and every element stored in the unsorted array to be compared with the temp. Whatever the element, whatever the index we have taken by the I, whatever the element will be, will that index will be pointing towards, that will be stored in the temp. At the end, number of j plus 1 is equals to temp. And at the last, I have printed the shorted elements. If you have any doubts, just let me know. So until now, we have learned three sorting algorithms, that is bubble sort, selection sort, and insertion sort. Now let us try to roughly analyze the algorithm and find its time complexity. So starting with the bubble sort. Let me do here. So, so for analyzing any algorithm or the code or anything, you need to assume that each and every step performed will take a 1 unit of time. So for example, if I'm writing, I'm writing a code for addition of two numbers. So I'll be first of all declaring that variables. How many variables will I need? That will be 3 variables of any data type, whatever the value I want to add. But for now, this is an example, so let us consider the values. So each and every element, each and every statement over here will take how much amount of time? We are assuming that every statement takes 1 unit of time for execution time. So there is no loop. If there is no loop and the statement we are writing, that is just for the declaration, or performing a task in a single statement only, then it will just take the 1 unit of time. So this will be taking the first statement will be taking 1 unit of time. Next, this is also the single statement. We don't have any loop or it is not iterating multiple times. So again, this statement is taking 1 unit of time, and this will also take the 1 unit of time. So the time complexity is equals to the addition of time taken by each and every statement, the summation, I can say summation of each and every statement, time taken by each and every statement. So it is 1 plus 1 plus 1. So while we started the second chapter analysis, we had learned some order of growth, where we had learned first the constant, that is n, that has the least execution time, then log n, then n log n, then n square, n cube, 2 raised to n, and at the end n factorial. That way we had seen the order of growth. First of all, it was constant, that was n, then log n, then it was n log n, then it was n square, n cube, 2 raised to n, and n factorial. So this was the order of growth we have learned. So for this program, the addition of two numbers, what is the complexity? That is 3. That is any constant number. If there are many more statements without the loop in it, then it would be having the constant. So the complexity for this program is big O of 3, that is constant. Now let us consider another example, having a loop. Now I am taking one variable, that is integer I, and taking a loop, for loop, that integer I is equals to 0, I less than or equal to 10, and I plus plus. And what I am doing in this is I am just printing the value of I every time, percentage d comma I. So now first is a declaration statement. So how much time will it take for the execution? Just a 1 unit of time. Now, for the for loop, let us see how much time for loop takes. How many times for loop will be executed? How many times for loop will be executed? Can anyone say how many times the for? Let us check how many times the for loop is executed. For loop will be executed until and unless this condition gets false. Let us check it out. For the first iteration, my I will be 0. For the next iteration, I will be 1. So it is less than 10. When I will be 1, it is less than 10. Again, for the third iteration, I will be 2, which is less than 10. Again, I will be 3, that is less than 10. Again, I will be 4, that is less than 10. 5, that is less than 10. Moving on to when I is equal to 10, which is not less than 10. So from 0 to 10, this one step, that is the execution of only this for loop statement, will be executed 11 times. 0 to 10 means 11. If I write over here the n, then it will be executed n plus 1 times. Why? At the end of every loop, you are doing I plus plus. So once you will get the I as 9, then again it will be I plus plus. So I will be my 10. Then the condition will be checked. So for every n, it will be incremented n plus 1 times. This condition will be checked every time. So, so for loop will be executed n plus 1 time. Any loop that in which you are checking some condition will be executed n plus 1 times. Now, now the statement inside the loop. How many times this statement will be executed? This statement will only be executed n times, because once the condition is false, the statement inside the loop will not be executed. So the statement inside the loop will be executed n plus 1 times. Are you having any doubts in any query? Okay. So now what is the complexity for this? So T is equals to 1 plus n plus 1 plus n plus 1. So what will be the complexity for this? 2n plus 3. So for this program, my complexity will be big O of n. In the above program, the complexity was in constant. Now it is big O of n. Why big O of n? When you are getting the equation, the highest degree of coefficient or else the highest order of an equation is considered to be your complexity. The highest degree of a polynomial or the highest order in your equation is considered to be your complexity, your time complexity. Now let us take the space complexity. What is the space taken over here? It is I. The I is incremented 10 times. So this I, over here we are incrementing it 10 times, as in the loop we have given it I less than or equals to 10. But if I'm keeping it n, then how much space will be needed to store the values of I? So that will be n. So the space needed for this program is 10. But if I'm not giving the 10 and incrementing the I till n, so the space complexity will be also be bigger of n, because I will be needing n blocks to store the n values. Any doubts in what we did, what I have explained right now? The basic concept of time and space complexity. Anybody is having any doubts till now in this whatever I have explained? Okay. So for this lab, let us keep till here. In the next lab, We'll be doing the analysis of bubble shot, selection shot, insertion shot, and then we'll be moving towards the merge shot and quick shot. So all of you give me your attendance in the chat box and then you can leave the session.